Hi. Now we discuss the atomic properties. Atomic properties are the most important because the chemical reactivity of every element depends on some atomic properties like ionization enthalpy, electron affinity, atomic size, etc., electropositivity, like that. Now we discuss ionization enthalpy. What are its trends? Trends means in the periodic table, how does ionization enthalpy changes? In a period, we observe the trend from left to right. In a group, we observe the trends top to bottom. First of all, we learn what is ionization enthalpy. It is a quantitative measurement of the tendency of an atom of losing electron. It is a quantitative measurement of the tendency of an atom to lose electrons. It means quantitative measurement means how much energy is required for the electrons to go out of the atom. Because in every chemical reaction, we know that electrons participate. So, ionization enthalpy, IE, in short we call it IE, ionization enthalpy. It is a quantitative measurement of a tendency of losing electrons, by an atom. It means quantitatively you have to calculate. We should have some information about quantitative measurements, or quantitatively we should know the energy required to remove the electron from an atom. Which atom means neutral, isolated, and gaseous an atom. From a gaseous, isolated, and neutral atom, if you wanted to remove electron, the energy required is called ionization enthalpy. Okay, and the units are, what are the units? We calculate this ionization energy or enthalpy in kilocalories per mole or kilojoules per mole as a CGS units and SI units. This is a CGS units and SI units are kilojoules per mole. Okay. Definition and the units we use it to calculate the ionization enthalpy. Now, what is its trend? Means how does it change across the period or down the group in the periodic table? Then only we can better understand the chemical nature of an atom. How easily an atom is losing electron, how easily an atom in a period in a group losing electron, where it is more easy or where it is more difficult. Let us see. Before that, we should have some broad idea that generally metals lose electrons, losing tendency is more. Non-metals gaining tendency is more. Non-metals always they gain electrons. Metals they lose electrons. Metalloids, between these two metals and non-metal, metalloids are there. They lose and gain electrons based on the experimental conditions. Okay. Now let us see down the group or across the period. Let us take first across the period. Across the period, Means when you go from left to right, what happens? IE value increases or decreases. What is the reason? Or any deviations are there? If there is a deviations, general, we call it a general trend. If there is no deviations, we call it a regular trend. So this word is also very important for competitive examination point of view. There are two words. There is, for example, you take second period. First period only two elements, hydrogen and helium only. Second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. These are the second period elements. Second period elements. So, based on the electronic configuration, IE values depend. Based on the electron configurations, IE values depend. General trend is left to right IE value should increase. Left to right general trend is increasing trend. IE values always increase because left to right size decreases. Lithium is big atom, beryllium is a little smaller, boron is little smaller, carbon, nitrogen, oxygen, fluorine suddenly increases size. Size will tell you the trend of ionization enthalpy. How? Let us see now. Here, lithium is big atom, left to right size decreases. Electron configuration of lithium is 1s2 2s1. 1s2 2s1. That is the electron configuration of lithium. Atomic number is 3. 3 electrons are distributed in the s orbitals only. 1s2 2s1. 1s2 2s1. Okay. Now in beryllium 1s2 2s2. 1s2 2s2. S orbital is completely finished in beryllium. But in lithium, S orbital has only 1 electron out of 2. It can accommodate 2 electrons out of 2. It has only 1. But when you come to boron, smaller it is than beryllium. Its configuration is 1s2 2s2 2p1. When you come to carbon, 1s2 2s2 2p x1 and y1, because p orbital contains 3 orbitals. P sublevel contains 3 orbitals, px, py, pz. So first electron in boron, it is in the px orbital. When you come to the carbon, x1 y1, total 6 electrons. Atomic number is 6. Atomic number 5, atomic number 4, atomic number 3, 3, 4, 5, 6. When you come to nitrogen, you know very well, 1s2, 2s2, 2px1, 2py1, 2pz1. So, you are able to understand, I think, what is happening in the electron configuration. And when you come to oxygen, still smaller than nitrogen, it has starting pairing. According to Hund's rule, first any sublevel, if it has more than 1 orbital, first they are filled with a 1 electron, means half filled. After filling with 1 electron, then only pairing starts. So pairing starts where here, for IIT examination point of view or NEET level, pairing starts from which orbital here? Pairing starts from px in oxygen. In oxygen, px1 becomes a px2. It means pairing started in oxygen only, in the p orbitals. But s orbital has pairing take place, but here only 1 orbital. S sublevel contains only 1 orbital. P sublevel contains 3 orbitals. When it comes more than 1 orbital, then only the question arises, that is how they are filled. First they are filled with 1 electron, half filled condition, then only pairing starts. So a question there may be in the objective type of in the competitive examination of any is, in the second period, starting of pairing. Pairing starts from which element? Means oxygen. Okay. Now oxygen configuration is 1s2, 2s2, 2px2, y1, z1. Pairing started. In fluorine still smaller. Neon is very big. Atomic size decreases from lithium to fluorine only. But after fluorine, suddenly increases in neon. Because in neon, octet S2P6 octet structure is obtained. Means not only this period, in the periodic table, every period ends with the biggest atom. Except the last inert gases, means every period ends with inert gas, noble gas. Because why I say noble gas? Because all are gases. In this group, inert gases, 18th group, all are gases. So we call them noble gases or inert gases. Zero group elements, they are also called. So every period ends with the zero group element or inert gas with the configuration S2P6. Whenever completely filled the sublevel or orbit, then size increases. Here suddenly size increases in neon. Okay. Here what is 1s2, 2s2, 2p6. Complete fluorine is 1s2, 2s2, 2p, x2, y2, z1. Here in neon comes 1s2, 2s2, 2p6 completely filled. This is now we have to discuss the trends of IE values from left to right. That is our topic now. Let us see now. Here size decreases, IE value should increase. If size decreases, IU value should be increased because in the small atom it requires more energy to remove. It means definitely from lithium to beryllium, IU value should be increased. So what is its value increased? It is 520 here. 520 kilojoules. In lithium, 520 kilojoules. When it comes to beryllium, increases to lot. Means its value is, but you need not by heart, 890 roughly. 890 kilojoules. Why? This reason is because the size is decreased. When size is decreased, automatically IE value increases. But here two factors are there. Here S2 electron is paired, S electron is paired. Here single electron, easy to take it away, to take it out easily. But when an electron is paired here, it is difficult to take paired electron. So 500 to almost doubled, nearly 899 actual value is almost doubled. Generally it increases slowly, but here double means two factors are influencing. First factor is size decreased, second factor is S2 electrons are paired. Pairing electron is always very difficult to take out. Unpaired electron, lithium unpaired electron, easily we can take it out with less energy. So in lithium it is 520 only. When it comes to beryllium, suddenly increased. Now when you come to beryllium to boron, see here 2p electron, we have to remove the electron from p orbital or p sublevel. Instead of increasing, it will decrease. Why? This is the competitive exam, IIT, JEE, main and advanced and NEET level and all other competitive examinations. Here only question will be asked. What is the reason here? Unpaired electron, one reason. Unpaired electron, it is very easy to remove. Another reason is p orbital penetration is less than S. Highly penetrating electrons are S electrons. Penetration concept also you should know. Then only you can answer easily this type of questions. Penetration means, what is penetration? Different electrons are there. S electron, P electrons, D electrons, F electrons. S, P, D, F electrons are there. Penetration means the tendency of getting attracted towards the nucleus. S electrons are attracted towards the nucleus high level. Next comes P. Next comes D. Least F electrons. Penetration is least. So when compared with S electrons, P electrons they have less penetration power. So it means less attraction towards the nucleus. It can be easily taken out. So E value from here to here, instead of increasing, decreases 801 kilojoules. Here in the example, this is the question, area of the question to ask in the competitive examination. What is the general trend? Left to right to increase, should increase. But instead of increasing, decreases. Why? Two factors are there. One factor is a smaller size. Another factor is less penetrating electrons. P electrons are less penetrating towards the nucleus. Nucleus is positively charged. Electrons are negatively charged. There is attraction. Here, since P electrons have less penetration, they can get attracted towards the nucleus more. That is why it is a very difficult here. S electrons, P electrons, less penetration, so easily we are taking. When compared with beryllium, it is easy to take electron, outermost electron in beryllium. Boron. In boron, it is very easy to take it electron because of two reasons. What is that reason I told? Here, unpaired electron, one is another is less penetration. Unpaired electron, one factor, another is less penetration. Because of these two factors, it became 801 kilojoules instead of nearly 900. 100 kilojoules reduced. Okay, when you come to boron to carbon, again, common general trend, that is increasing trend only. So its value is should increase to 1000 or 1100, nearly 1080, nearly 1100, nearly 1100 kilojoules in carbon. Yes, correct. Here only one factor reason for the increase. What is the factor? Size only, not electron configuration. Here size and electron configuration. Here only size. Size decreased, IE value increased. General trend only. General trend. When we come to carbon to nitrogen, IE value suddenly increases. Here 1100, when come to nitrogen 1000 to 1300, nitrogen is 1400. Nitrogen is 1400 kilojoules. 1400 kilojoules raised. What is the reason? Here there is a chance of asking question in the competitive examination. Why there is increase instead of here left to right should increase, but lot of increase. Increasing is very high. Why sudden increase IE value? Here all electrons are off field condition. Off field condition atoms are stable according to Hund's rule. Whenever any sublevel contains more than one orbital, if they are filled with one electron, off field condition, it has more stable than the other configurations. So nitrogen is more stable than carbon. Nitrogen is more stable than carbon because of off field condition. So increased stability increases, energy increases to remove the electron. Nitrogen is very stable. It is very difficult to take electron because of two reasons. Size decreased, electron configuration is off field condition. Hund's rule applicable. Okay. When comes to nitrogen oxygen, what happened here? 1400 becomes less only. 1400 becomes 1300. 100 decreased. 100 decreased from nitrogen because only one factor influences, that is the size. Because oxygen is smaller than nitrogen, so increase smaller than decreased here. We should remember this: nitrogen to oxygen, instead of increasing, decreased. Instead of increasing, decreased. Also, it is an area of asking a question. Why? Because here off-field condition to off-field condition is disturbed. Off-field condition is disturbed. So it is very easy to take electron. So it is a decrease from 1400 to 1300. 100 decreased, easy. So It's very difficult to take electron from nitrogen when compared with oxygen. From oxygen to fluorine, oxygen to fluorine, yes, size factor, size increases, Here it decreased because of observability condition is disturbed. From oxygen to fluorine, again starts increasing. How much increased in fluorine? 1600 or 1700 nearly. 1700 kilojoules. Nobody is supposed to by heart these values. Reason you should know whether it increases or decreases, why. According to IIT, JEE main or advanced level point of view, numerical values need not by heart. You should know the reason why increasing, why decreasing. So never worry about the values. Even I write the values also, need not worry. Left to right, increase or decrease of why. Sometimes increases, sometimes decreases. Sometimes more increase, sometimes less increase. Based on the size and the electron configuration. You should know this. Everybody should know this. Those are going to appear for competitive examinations. Okay. So, it is increased to from 1300 to increased how much? 1300 to 1700 nearly. 1700 in. From fluorine to neon. Neon is completely filled sublevel. It has orbit, second orbit is completely filled. S2p6 configuration. Neon has a S2p6 configuration. So, highly stable. First stability, this only. Any atom, if it has a configuration S2p6 in the outermost orbit, highly stable. Next comes observability condition. Except these two, all are not stable. So, Hund's rule everybody should know, and last octet rule also we should know. Now, what is the value of neon 2000? Neon has a 2000 kilojoules per mole. 2000 kilojoules per mole. So, if you do not understand this, you cannot be successful in understanding the chemical reactions in all other chapters, whether it is organic chemistry or any other chemistry. So, you should know repeatedly and read these reasons also. Reason from lithium to beryl, what is the reason? Lithium to pairing of electron and also smaller size. Together resulted increase, nearly 400 increased. Two factors. That factor also everybody should understand. If you remember only one factor, not enough. Why lot of increase? Two factors. If only one factor is there, little increase. When come to beryllium to boron, size factor is there, penetration. Penetration less when it opposite factors is there. This is contributing, size is a contributing factor for the increase, whereas the penetrative there is a not contributing to increase. It decreases finally only 100 only. So among the two factors, what do you understand? One is a factor which increases IU value, another factor which decreases the IU value, opposite. From here to here, both factors are positive factors to increase the value. Smaller size is increasing factor of IU value. Another one, pairing of electron, increasing factor. Both are increasing the IU value. So for that reason, 500 to 900 increase. This is actually main level and advanced level. You have to understand up to this level. Because these points are not given any in the NCRT also. NCRT will give the plain structure of or plain concept only. Now, beryllium to boron, yes. Beryllium to boron, one is supporting factor to increase the IU value, another is a opposing factor to decrease. Supporting factor is smaller size, opposing factor is a penetration power is less than when compared with S electrons. When you come to boron to carbon, yes, only one factor, size only. Size, smaller size increased from 800 to 1100. Size factor only. Okay. Now, when you come to nitrogen, two factors, where 1100 to 1400. Two factors. Both are positive factors, both are increasing factors only. What is one? First factor, smaller size, increases the IU value. Another factor is observability condition. Yes, that is also increasing factor of IU value. So both are positive factors to increase the IU value. For that reason, 1400. Next, when you come to nitrogen oxygen, again, one is positive factor, one is a negative factor. Positive factor is smaller size, it increases the IU value. But another factor is a upfield condition is disturbed. So it is a decreasing factor. For that reason, from nitrogen to oxygen, only 100 decreased. Because here upfield condition, stability more. So instead of increasing, decreases here. Instead of increasing here, decreases. So to these two boxes, you should fix in your mind, which will be asked in any examination of competition. Now, after this, here general trend only. Where fluorine to neon. General trend that, but what is that? Inert gases will have highest in every period, across the period, or every period ends with the highest IE value because they are all inert gases or stable gases, zero group elements. Thank you.